Welcome to the last part of the vectors video. In this video we will talk about vector functions, or also known as vector operations. When performing operations such as mathematical operations on vectors, the operation is applied to vector elements memberwise. This means that each element from the first vector operand is modified by the element in the same corresponding position in the second vector operand in order to determine the value at the corresponding position of the resulting vector. So what does that all mean? To know, we'll first create two vectors to combine. I'll just say vector 1 and give the values as 4, 5, 4, 3, 1, and 6. And then we're going to create a second vector and give the values of 1, 1, 1, 1, and 1. Alright, second part. Creating arithmetic combinations of the vectors. So let's say v1 plus v2, and we're going to highlight everything and run it. We see that we got 6, 5, 4, 2, and 7. So basically what's happening here is that v1 and v2 are being added from top to bottom. 5 plus 1 is 6, 4 plus 1 is 5, 3 plus 1 is 4, 1 plus 1 is 2, and 6 plus 1 is 7. Add a vector to itself. Alright, that's going to be the next task, but let's write more arithmetic combinations with vectors. v1 minus v2. Run. And then let's try v1 times v2. Basically, everything's going to come out the same because we're multiplying by 1. Alright, let's add a vector to itself. v1 plus v1. Can we do that? Let's see. 10, 8, 6, 2, 12. We cannot apply math operators to strings, but we can use functions like paste to concatenate the elements of two vectors. Create two vectors to combine with string data. Okay. Create a vector function called banding and whatever flows. And this variable called band combo will be used to produce a new name table. Okay. Alright, from there we're going to create a new variable, new band name, and we're going to say okay. Paste band name and band combo, and highlight and run. The new band name is River Table Flows Tree. What is recycling in R? Recycling basically is using a number, even though there could be cases of an inequality, and in two operand vectors. So let's see if we create two unequal elements. So we're going to say this has 3, 4. And then vector 4, it'll just have C1, 0, just 2. And what happens if we try to add them? We'll see recycling happening. Right? Oops, we gotta create a new variable. I'm gonna run this. Longer object is not a multiple short object. Okay, so again, we're getting a warning message. It doesn't necessarily mean that we're doing something wrong, but it can be an indication of it. So 1 and 3 is being added 4, and 0 plus 4 is being added, so it's 4, and it's getting recycled at this point. This function is getting recycled. So 1 comes back over here, 6 plus 1 is 7, and then 0. 0 plus 1 is 1, and then 1 comes back up, 3 plus 1 is 4. Recycling will occur no matter if the longer vector is the first or second operand. R will give you a warning message. It does not mean what we did is wrong, it's just a sign that there could be an error. Everything is a vector. What happens if you add a vector and a regular single value scalar? Create a vector number 1 to 5 and add a scalar to the vector. Okay, so let's create add scalar. It's going to be the name of our vector. So I'm going to say, vector 1 through 5, and then add scalar. I'm going to add 4 to it. Run it. So 4 is being added to every element from 1 to 5. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. 4 plus 4 is 8. And 4 plus 5 is 9. Things we need to understand. Even though we thought we created a new scalar, we were just creating a vector with a single element of 1. This is why R prints 1 in front of results. It is telling you that it is showing a vector starting at element 1. To get a length of characters from a string, use nchar. Alright, we're going to use nchar. Okay. Let's see. Nchar. My name. See the length of John. We get 4. More important things to notice. Because everything is a vector, it means everything we have learned so far has actually applied to vector, not single values. These are referred to as vectorized functions and will run faster than non-vector approaches. These two lines of code are the same. This means that we can use any function on a vector and it will act the same vectorized memorized manner. The function will result in a new vector where the function transformation has been applied to each individual element in order. For example, consider the round function described in the previous chapter. The function rounds the given argument to the nearest whole number. Create a vector of numbers. We have a vector of numbers here. Perform the vectorized operation. We're going to round it to the nearest whole number. Print the results and each element is rounded. So the rounding will apply to everything in the function. 3.98 turns into 4.0. 8 turns into 8.0. Since we're using decimals, so everything will be turned into decimal. So 8 was a whole number, but now it's a decimal. Something to take notice. This vectorization process is extremely powerful and a significant factor of what makes R an efficient language for working with large data sets. Thank you for watching, and if you have any questions, please leave a comment, and I'll see you in the next video.